Record. So, good evening. We're back. We're actually out in the construction pavilion for this part of the lesson on our truss construction. We have our sample right here that I'm going to be referring to throughout the lesson. You were all given a handout to accompany tonight's lesson, and I'm going to go through that with you now. So, our last class, we actually we're using what we refer to as backward design. And so what I did in our last class, we pre-cut, and we actually made all these trusses. We only needed 6 trusses because our structure is small. It's 8 feet wide and 10 feet long. So we required 6 trusses. So we actually cut those and constructed them Monday night. And now tonight's class, I'm going to help everyone understand the terms associated with building a truss, the terms associated with roof framing, the science behind what we did in the last class, and of course we'll answer any questions that the students may have. So as I'm going through this, feel free to jump in. If there's something that doesn't quite click, hey, what do you mean? How does that work? Feel free to do that. So your handout in front of you and the prototype that you're looking at here is this is called a common truss, a common gable truss. Very typical in residential construction. So the roof on your home, many of you on your home would probably slope in 2 directions, very similar to what you see in our prototype and what we're going to use to finish our shed out. So I thought what we'd do is start on page 1. And we'll talk about truss terms. Now the terms that I'm going to refer to are typically used to describe the various parts of wood trusses. The truss profile, the span, the heel height, overall height, the overhang, and web configurations depend on the specific design conditions and will vary by application. So just to repeat, our initial, this truss that we made is for a very narrow building. It's 8 feet wide. So it's a very small truss. It's only about 20 inches high, and it's 8 feet wide. An average home would be 24 feet wide, so this bottom cord would be 3 times the length that you see right here. So you can just visualize that. But this will give you the basics, and you apply the same principles that you learn here, you can apply to truss building for a 24-foot garage. Say you're going to build a garage and you want to make your own trusses. You've learned enough here that you should be able to do that. There are 2 basic types of trusses. The pitched or common truss, which you have here, is characterized by its triangular shape and is often used for roof construction. Some common truss names are based on their design, such as the king post. That's the name of an actual truss, and ironically it's the one that we built because, as you can see, we have one post in the middle supporting our joint at the top here, the peak, and this is referred to as a king post truss. Now if you look at the design, by the way we nail this together, we created a triangle. And the triangles, you're going to learn, are the secret to the strength of a truss. The cord size and web configuration are all determined by the span and the load and spacing. All truss designs are optimized to provide the most economical application. So, again, ours is a very small, easily to design truss and easy to make. The bigger trusses, for bigger homes, while carpenters can construct them themselves, most times we end up buying them from a truss plant, where they have these huge work areas where they can use special connectors and all the engineering is provided, and they can make those trusses and have them delivered to your site. That's traditionally what happens in the residential industry. Some more terminology involved with our truss construction. So, a truss is a pre-built structure capable of supporting a load over a given span. A truss consists of one or more triangles in its construction. So again, I'll re-emphasize the strength, and you'll see this in bigger trusses, the strength of a truss, you know, we go back to that triangle. And in fact, when we did our little lesson on roof framing, all roof framing is based on the right angle triangle. And that's what you see here, a right angle triangle. So that's why we did so much work in the math course to do with the Pythagoras theorem, because we applied that math to calculate the length of our rafter. You see a right angle triangle. So the hypotenuse, this being the hypotenuse of a right angle triangle, we use that math to calculate the length of this top chord on the truss, as many of you went through that with me in the math course. We have a variety of cuts involved that we made in our last class. So where the two top chords, maybe I'll tell you the name of these items first. So this member is called a top chord. We have two of them. This is the top chord, and of course that's a top chord. And this chord, this is the bottom chord, and that would end up forming actually in our shed construction as well as in home construction. That becomes effectively your ceiling joist. So in a residential one-story home, this would be your ceiling joist, and of course it would support the strapping and the drywall and the light fixtures and whatever insulation goes in between the... So that's what weight would be. This would support all that weight. Plus it works in combination with our triangles in supporting any snow load and all that, those other things that we took into consideration during the construction. There's a few joints here. So the cut that we made at the top, and you notice it again on the end of our rafter or our top chord, is called a plumb cut, and that's so when our fascia is attached to the front, you can probably start to picture now what that's going to look like. Many of you in your homes, you would notice on the front of that now would be a piece of rain gutter, and all the shingling and the roof sheathing and shingling will be on here, and this sheds the water down and into the roof gutter. So that's called a plumb cut. It's a plumb cut here in the middle, and it's also a plumb cut, of course, on the other end of your house. I think everybody understood that the other night when we went through this. The other particular cut that we're dealing with here is along our bottom chord, and it occurs at the outside of the wall, and it's again a sloping action, and that's called a scarf cut. And we laid those cuts out, as you will recall, Monday night with our framing square, and some of you want to use your speed square. So I'm old school, so I use my framing square, but certainly you can use the speed square or a framing square to lay out the angles for these cuts based on the roof framing science that we went through. So, the other thing that's unique about our truss, we took these off so you could see these joints clearly, but when we're done, we're going to put back our gusset plates that tie these joints together. So it ties the bottom chord and the top chord together, making a strong joint. Now, we did it by hand, and then we have one here in the middle that covered the entire king post, and it tied the bottom chord and the top chord of these two rafters all together, and we had it nicely fitted. You recall doing that the other night. So that adds great strength. We're not just relying on nails, nailing these pieces together. We want nice gusset plates over that. Now in the residential industry and in the truss industry, in the factories, they have engineered plate. This is all engineered, and they have metal plates that are pointed on one end, and they use a hydraulic press that connects one on this side and one on the other side, and just makes a super strong joint. And again, it's all engineered, and you know, that's a big part of the reason why most of us, you know, when you're building a garage or a home, you usually end up ordering your trusses from the plant, because they come all that engineered design is built in, and the standards are met for the engineering. So, a couple of other things before we wrap this up, because we have some work to do. We have to install these joists or trusses on our roof, which I brought it out here so I could give you a real good picture. Students have done great. They've got the shed, the floor is constructed, all the walls are constructed, and we're ready. We have our rafters built. We're going to be installing them on top of the walls in the next class, and maybe a little bit after we're done here tonight. So we want to refer a few other points about our construction that took place here. So we cut our plumb cuts using the cut of our roof, which, as the students have acknowledged, is 4 and 12, and that's the minimum span that you can use if you want to use traditional asphalt 3-in-1 shingles. The manufacturer will not guarantee that their shingles will keep your roof dry or your house dry if you use a slope lower than 4 and 12. You have to go into a different application then to watertight your home. So 4 and 12 is the cut we used, and that simply means that for every 12 inches in, you go from the outside edge of your building. Every 12 inches in we went up 4 inches. So if you can picture this, we went in 1 foot, we went up 4, we went in another foot from there, and we went up another 4, we went in another foot and went up another 4, and the final foot, 4 feet, which was our span, because our run of our rafter is 1/2 of the span of the building. The building is 8 feet wide, so our center point is 4 feet. That's pretty straightforward. So we went in 4 feet, and we had a rise of 16 inches. So that gives us a 4 and 12 pitch, and that will support the sheathing and the 3-in-1 shingles and the roofing system that we installed. This will keep us nice and dry, keep the building nice and dry for many years. Our 4 and 12 design incorporated the basic design of a truss. You need your span, which is the width of the building. This building is 8 feet wide. So, again, repeating, our center point, or our span for our rafter, the run for our rafter, our truss, is 1/2 of that distance, because of course we have 1/2 going that way and 1/2 going that way. So it's not really complicated. As I mentioned in our class the other night, all roof framing is based on what you see right here, on a right angle triangle. And we use that concept, and we use that Pythagoras theorem, and some other stuff that, we don't have time to go into tonight. If we were making this video an hour long, we could cover the whole construction process that we went through the other night. But to kind of wrap things up, our students, as I say, built these trusses the other night. So now when I refer to a scarf cut on this top cord here, because they cut them and put them together, I laid it out for them, and they cut them and put them together. Now they know, okay, that I was wondering what that scarf was called. So it's called a scarf joint. That's their plumb cut. And all of my references tonight to terms, I'm hoping make a little more sense than if I had just done this step first and then got them to cut them all and put them all together. It's just a little strategy we're trying with the learning for our students. So, again, little wrap up, little review. King post truss, bottom cord, top cords, right? Common truss, the whole unit is called a common truss, slopes in both directions. And this will work. We're going to install those, and then we'll put our plywood on it, and we'll build a little overhang. I'll try and give you a picture of some of what this will look like when it's finished. I'm going to swing this right around so you can see. There's where we're looking. The full-time students, of course, are ahead of us because they're here all day, and we do our evening classes, and we're doing all right. We have till the end of semester to finish this, so we shouldn't have any problem meeting that deadline. So there's a little peek at what our finished product should look like, and we're going to get to work now. So thanks very much.